So here we go, 3.7b, page number 281, bottom of the page, joint and other variation combinations. So in the last section, we talked about direct variation, and we talked about inverse variation. And we had mentioned the difference between the two is directly proportional, or direct variation is multiply. Inverse variation or inverse proportional is going to be division. Sometimes you are going to do a combination of both direct and inverse, and therefore there's different ways to word this. So what we're going to do here is, for example, let's look at page 282, top of the page. If we have something like y, give me the pen, y equals kx, what you say there is y varies directly with x. But if there is a second variable on that right-hand side, because remember k is a number, so x and z are the variables. So if I have a second number, I will say y varies jointly with x and z. Jointly means that we are multiplying. So jointly means multiply x and z. So the second example is z equals krs squared. And the way that's read is z, my arrow, z varies jointly with r and the square of s, or with s squared. Sometimes you might have something that's really goofy, like v equals kt over P. And this is when, in science, when you're dealing with volume, temperature, and pressure. And this says V is directly proportional to T and inversely proportional to P. So we're multiplying and dividing. So it's directly proportional and inversely proportional. And then finally, we've got this last one here in the purple box, F equals K m1, m2 over r squared. So this m1 and m2 maybe are two different masses. M for mass. Since we have two different ones, we need to separate those by calling one mass 1 and one mass 2. So this says F varies jointly with m1 and m2 and inversely with the square of r. Now remember, I said jointly because we're multiplying two variables here, just like up here. I said jointly. If I say it varies directly, that means there's only one variable here. If there were two variables, like if this was a z, I would say v varies jointly to t and z, or with t and z, and inversely to p. So it's all getting down the vocabulary. And that seems to be so much of the work when you're dealing with math, is getting the vocabulary. Okay, example 4. So let's write the equation first. Y, what's it say, varies jointly. So I know I'm going to have multiplication. I know there's going to be two variables since it says jointly, with x and the square of z. Okay, notice my z's have a little line through the middle there so that you don't get them confused with the 2. Okay, so that's my equation. When x is 5, remember we're finding k first, z is 3, y is 180. So they've given me everything I need to put in here to find k. So 180 for y equals k times x times z. So 180 equals 945. K, 3 times 3 is 9, times 5 is 45. Divide by 45, divide by 45, and you get k equals 4. So now that I know that, I can put that into my original equation. So let's go ahead and write that over here in red. Y equals 4xz squared. So I found k. Now I read the rest of the problem. Find y when x is 2 and z is 4. So y equals 4 times 2 times 16. So y equals 4 times 2 is 8. 8 times 16 is 128. So that ends up being my answer. Find y. We found y there. So remember, you find k first, and then you plug k in, and then you plug the rest of what they give you, and they have to give you enough stuff so that it's easy to find what they're looking for. Okay, example 5. So in electricity, the resistance of a cable, how much pushback you have as electricity is going through it. That's why, when you're holding a wire and it gets hot, that's your resistance. That produces heat, and that's what's happening here. The resistance of a cable, so let's call resistance R. It says the resistance of a cable is directly proportional. So I know I'm going to multiply directly proportional to what? Oh, its length. Okay? And inversely proportional to the square of the diameter. So the diameter squared. Okay, so there's my formula. First thing I'm doing, again, finding k. So let's read and see what they give me. If a 100-foot cable, so a 100-foot cable would be the length. 100-foot cable, 0.5 inches in diameter. This is diameter, so this is 0.5, and it says to square it. Has a resistance of 0.2 ohms. You don't really need to know what an ohm is, but we'll just put the number there. Okay, so now that gives us enough to find k. So we multiply all of this through, and we get k equals 0.0005. So let's rewrite this blue equation with the k that we now have. Okay, so we found out what k is. All right, what's the rest of it say? What will be the resistance? So we're looking for that. So they're going to have to give me length and diameter in order for me to solve for R. So what do they give me? They say that R equals, let me just kind of write this out real quick. Do they give me a length? They better. What would be the resistance of a cable made from the same material if it is 200 feet long? So the length is 200. And the diameter is 0.25. That being the case, we are going to multiply these two, take that answer and divide it by 0.25, and our resistance is going to be 1.6 ohms. Okay, again, it doesn't matter what ohms are. All that matters is that you find out what the R is. And that's it for 3.7. So direct variation is multiply. Inverse variation is division. And remember, you're finding the k first and then rewriting the equation with the k figured out, like here. And then you are putting in the information that they give you in the rest of the problem, and you solve for whatever variable they're looking at. And that is it for 3.7.